So finishing up conditional statements, like I said, we just have these like 4 topics. They're mainly this idea right here. So you have these different types of statements. Where's my pencil at? Of course, it's not going to work. Well, let me close out of notes and see if that works. There we go. Okay. So you have the original statement. I'm just going to call it the original. This is talking about an if-then statement. Okay, so you have if-then. I'm going to use P and Q. I kind of hate to do that, but it works well for this. So you have the original, and it's if P, then Q. So you say if something, and then if this happens, then this will happen. So if P, then Q. Oh, different color there. Now it's not going to let me change colors. What in the world is happening? There we go. Okay. So you have if this happens, then P. I think the example we used the other day is like if the stoplight is red, then you must stop. So you have these 2 statements around the if then. So I'm going to call that the original. The converse flips those, and it says if Q, then P. If Q, then P. So if you must stop, then the stoplight is red. So it kind of flips those statements right there. The inverse, you always go back to the original. So back to the original is P and Q. It's going to be not P and not Q. Okay? It's going to be not P and not Q. So it puts a not in there. If the stoplight is not red, then you must not stop. And then the contrapositive does both. It is going to flip it. It's going to put the Q over here, not Q, and then not P. So it flips it and puts the not. Okay? So in my random words here, the original is just the original. The converse flips it or switches it. I'll say flips it. Flips it. This puts the not in it. And this flips it and put the not. Okay. So those are what those words mean. So for example, this one right here, just to like see the example they have right here. If I need to go back there in just a second, that's fine. If a person is a professional athlete, then the person is a professional basketball player. So you identify what your P and your Q are to start. The P is a person is a professional athlete. The Q would be then the person is a professional basketball player. So the contrapositive is going to do both. Okay, so that tells us to do both. So we are going to flip it. Oops. We're going to flip it and put the not in there. Okay, so we flip it and we put the not in there. If a person is not a professional basketball player, then the person is not a professional athlete. For the converse would be you flip it. So just flipping it, we just put if the person is a professional basketball player, then the person is not a professional athlete. And then the inverse, you put the nots in there. So all we're doing is keeping it the same. If the person is if the person is not a professional athlete, then they are not a professional basketball player. We'll see if we talk about the truth values of these, but the way it ends up working is the original and the contrapositive are always the same, and the converse and the inverse are always the same. I'll hold off on that for just a second because I think there's a topic on that. But that is the idea behind these, and that's like all we really had to do today was talk about those topics. We'll go through the other topics real quick, but it is the same idea there. Oh, yeah, this one here, determining their truth values. All right, So the table below gives the color and cost of light bulbs. The given statement, that's the original. If the light bulb was red, then the light bulb costs $5. So the converse would be you flip it. So the light bulb costs $5. The light bulb was red. Okay. Let's go through the true, false as we go through these. If a light bulb is red, then the light bulb costs $5. Is that true? Yes. Red, $5 right there. Okay. If the light bulb costs $5, then the light bulb was red. Well, the only one that costs $5 is the red one, so that would also be true. Okay. The contrapositive, we are going to flip it and put the knots in there. So if it does not cost $5, then it is not red. And once again, if it doesn't cost $5, that means it's not a 5, and the red is not on there, so that would be true as well. The inverse is going to put the knot in there, so if it's not red, then it doesn't cost $5, and that would be true because the only $5 one is red. Okay. I'll save that real quick, but I want to do another one. So on this one, all the truth values ended up being the same. The rule for this, though, is... I got to generate one real quick. The rule for this is the original... I might go ahead and write that right here. Original and contrapositive have the same truth value, and the converse and inverse have the same truth value. Okay, with a note here that they can all be the same. Like the one we just did right there, they all ended up being true. But the rule is the original and the contrapositive have the same truth value. So if the original is true, the contrapositive is going to be true. But the converse and inverse usually have the same truth value too. Okay. I believe that rule always holds true. The weird thing is that they all can be true or they all can be false. That doesn't happen all the time though. So let me generate one more real quick. Yes, I think this is the one. I'm just going to go ahead and solve it real quick. So if a light bulb costs $3, then the light bulb is yellow. Well, if I look at my chart, I have 2 3s up there. I have, if it's green, it's $3, and if it's yellow, it's $3. So just because it's $3 doesn't mean it's going to be yellow. It could be green. So my original is false here, okay? My converse, if the light bulb was yellow, then it costs $3. That's going to be true. Like yellow only has one price, and it's $3. The contrapositive, if the light bulb was not yellow, then the light bulb did not cost $3. That's not true because it could be green and it could cost $3. So you use that information there, and basically, since the green and yellow light bulbs cost the same amount, it creates this. If in the inverse, if a light bulb did not cost $3 and the light bulb was not yellow, that would be true because if it didn't cost $3, it's either $5, $2, or $6, so it's got to be red, white, or purple, right? I went blank there for just a second, but so you can see there that the contrapositive and the original are the same, and the inverse and the converse are the same. But you just got to be careful on some of those. Don't just blindly go by that because they can all be the same like we did on that first one. All right, identifying some more negation ones. All right, let's look at this real quick and see if we can figure this out if we don't have to look at the words. If Mai is not practicing baseball, then Carlos is not dancing. All right, so Mal is practicing baseball or Carlos is not dancing. Let's go see if they have a chart real quick here. Oh, are you supposed to actually do a truth value table for each of these? Is that really the way they're going to show to do this? Oh, that's a pain. So, let's see if we can shortcut this. For it to be an equivalent, the truth values have to be exactly, the truth value tables have to be exactly the same. For a negation, they have to be exactly opposite. So I think maybe this one is a pain, because the easiest way to do this is to go through all the scenarios. Okay. So maybe we can just make a big chart here. First thing we need is not P and not Q. Okay, so not P and not Q is just going to be the opposite of these. False, false, true, true. False, true, false, true. All right, now that we have that, I think we can come up with our answers here. So our original statement is if Mal is not practicing baseball, so not practicing baseball, then Carlos is not dancing. Okay. So I'm making, if like we need to write it out, P would be Mal is practicing baseball. Q would be Carlos is not dancing. All right, so the rule for if then would be if the first is true and the second is false, and we're using the not P column right here. So not P, not Q. If not P, then not Q. So if the first is true and the second is false and the whole thing is false, all the others should be true. Okay, so that's my original. So now we got to compare all the other ones to that one. So Mal is practicing baseball. I'll just call this A, B, C, D. So for A right here, Mal is practicing baseball or Carlos is not dancing. All right. So for this one, we're looking at this column and this column, right? The rule for or would be it's only false if they're both false. So if I'm looking at the first column and the fourth column, that would be true, true. Here's false and false, right? So that would be false, and then false, true. Oops. False, true would be true. Okay. So those are going to be equivalent because they are the same. So for equivalent, the same, and negation would be completely opposite. My goodness. All right. So for B, Mal is not practicing baseball and Carlos is dancing. So which columns are we looking at here? We are going to look at not P and Q. The only one the order matters on is the if then. So my rule for and is if they're both true, it's true. So that would be this one right here, the third one. And then all the others should be false. Okay. Is that exact opposite? So compare it to the original one. Compare it. Oops. Go back and compare it to this one. Those are exact opposite, right? False, false, true, yes. So those are a negation. Next one, if Carlos is dancing, that's Q, then Mal is practicing baseball. So be careful. The Q comes first here, so I'm going to look at this one first and this one second. If you need to rewrite it, that's fine. So if the first is true and the second is false, then it's false. All the others should be true. And that looks like it's equivalent, right? That's the same. True, true, false, true. And then the last one, Carlos is dancing, that's Q, or Mal is not practicing baseball. So which columns am I using there? I'm using not P or Q. The rule for Q or not P is if they're both false, it's false. Otherwise, it's true. So false, true, true, true. Okay. Now I compare that to this. True, 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 false, false, true, true, true. They are not either. It is not exactly opposite. Some of them are the same. Some of them are different. So it's not exactly opposite and it's not the same. So it is neither. That's kind of a long problem. That kind of puts together like everything we've done so far. And the last topic here, we actually did this one the other day. I probably should have done it on Tuesday, but I didn't realize there was a basic and advanced one. It's that one where they give you a scenario. So if you brush your teeth twice a day, then you won't get cavity this year and you won't get gingivitis this year. Okay. So if you brush your teeth twice a day, you won't get a cavity or the dentist statement. So wait, we got a comma right there, so I'm guessing a parentheses. If Q is you get a cavity and R is you get gingivitis. So if the dentist says you won't get a cavity or gingivitis, it would be not Q and not R. Okay. So if you brush your teeth every day, twice a day, you won't get a cavity and you won't get gingivitis. So you got to write the dentist statement. And then you come down here and remember you look at this scenario that they give you to figure this out. To figure out the true false. So you don't brush your teeth every day, you get a cavity, but you don't get gingivitis. So it is false that we brushed our teeth every day. We do get a cavity, but we don't get gingivitis. So what happens when it's false, true, false? Okay. And we don't have a lot, or do we have done any with the three? Yeah, we did. There's one topic where we had three. But you just go step by step. It's not any different when you have three. Let's find not Q. Not Q would be the opposite of Q. So that's false. Not R would be the opposite of R. So that's true. Oops. Now let's find not Q and not R. So not Q and not R is only true if they're both true. So that's false. So now we say if P, then this one. So we're looking at the P in that one. That is going to be true because they're both false. Right? If then is only true if the first is true and the second is false. So if I'm looking at the first column, it's false. Looking at this column, it's false. So false, false would leave to true. The dentist statement is still true because... I don't know why, because you don't brush your teeth twice a day, you still got a cavity. So it's still true because you got the cavity, I guess. It's kind of hard to think about when you think about it like that. We could think about it for a minute, but just take it piece by piece. When you got the three there, find the not Q, find the not R, then find the not Q and not R. Oh man, I accidentally took away I clicked solve to make sure we had it right, and I took away my work here. So give me just 1 second. Let me type it back in here. Not R would be true. And then what was it? Not Q and not R. That would be false. All right. So that finishes up conditional statements.